Hi, everyone. Welcome. What I try and do every week is to take a technology that we might have heard of in our daily readings or, very often, and try and demystify it. So today, what I'm going to do is to take one technology which again is something which is talked about a lot, is a little bit into the future, but is super exciting. And that technology is quantum computing. I'm sure you've heard of quantum computing, and it's almost otherworldly, as you will see when I try and explain it as to what this technology really is. But to understand it, let's start with a joke. This is a joke about a cat which belonged to a gentleman called Schrodinger. And the joke goes, Schrodinger's cat walks into a bar and doesn't. Now, if you are laughing, then you have to be a student of physics, quantum physics, or at least of physics. If you are not, let me try and explain. So Schrodinger's cat theory, which is really this where this joke comes from, is a paradox which explains the seeming contradiction between what we see with our naked eye and what quantum theory tells what actually it is in the microscopic state. And those things can be different. So Schrodinger used this to disprove something which was called the Copenhagen interpretation of quantum mechanics. The interpretation states that a particle exists in all states at once until observed. I'll say that again. A particle exists in all states at once until it is observed. So Schrodinger's cat is in a box and it could be alive or it could be dead. However, till the box is opened, you would not be able to know whether it is alive or dead. You would not be able to know its states. It actually exists in both states, alive and dead at the same time, which to a rational brain might seem impossible. Now hold that thought, that impossible thought for a while we take a short leap from cats to computers. The ones which we use now, the computers which we use now on which I'm recording this actually follows the principles of a Turing machine. So in a Turing machine, information is encoded into bits, either ones or zeros. And one can then apply a series of operations and or not, etc. to those bits to perform any computation. A quantum computer is different. It uses what are called qubits or the quantum analog of bits. So now jump back to the cat. Much like the feline in the Schrodinger's box, a qubit is not permanently a zero or a one, unlike a bit, but it can actually be both at the same time. Only at the end of the computation or when the box is opened, you can know whether it is a zero or a one. But during the computation process, its exact state is indeterminate and can contain bits of both. Now, if this leaves you scratching your head as it left me mine, do not fret. In a 2017 Wall Street Journal interview, this is what Bill Gates said. Bill Gates, I know a lot of physics and a lot of math, and I'm sure we believe him. But the one place where they put up slides and it is hieroglyphics, it is quantum. I can't understand anything. Even the great Albert Einstein had some difficulty understanding the concept and dismissed it by famously saying that God does not play dice with the universe. What makes a quantum computer exciting is the ability to exploit these properties of quantum physics to form certain calculations far more efficiently and much faster than any computer or even a supercomputer. Thus, large corporations like Microsoft, IBM, and Google have been furiously working away on quantum computers. Sometime back, you must have read that Google claimed to have achieved what they called quantum supremacy, or the point when a quantum computer can perform a calculation that a traditional computer cannot complete in its lifetime. Google's quantum computer took 200 seconds to complete a calculation that would take a supercomputer 10,000 years to do, thus making it hundreds of millions times faster than any of today's machines. While all this is very impressive, what does it actually mean for us? It is difficult to comprehensively answer this question since we are venturing into an entirely new area of physics and a area very difficult to understand. And the future, I'm sure, will reveal use cases and solutions we have not even imagined yet. It's a bit like classical computing, Turing computing. We did not know how it will totally revolutionize our world. Uh, in the same way, quantum computing will be game changing for many industries. Take big data and analytics. We produce 3 exabytes of data every day, which, by the way, is equivalent to 300,000 libraries of Congress. Classical computers, driven by the flattening Moore's law, are reaching their limits of processing power. However, with the exponentially more powerful quantum computers, we could spot unseen patterns in very, very large data sets, integrate data from different data sets, and tackle the whole problem at once rather than analyzing it bit by manageable bit. This would be rocket fuel to artificial intelligence, with quantum computing providing quick feedback loops and collapsing the learning curve in machine learning. This will make AI more intuitive, make it expand to multiple industries, and who knows, perhaps help build artificial general intelligence. Still the stuff of science fiction and mad scientists. Online security will be massively impacted with our current data encryption strategies like two-factor authentication or public-private keys wilting under the massive assault of the sheer brute power of quantum computing. On the other hand, there will be formidable new cryptographic methods like quantum key distribution, where even if the message gets intercepted, no one can read it. Remember the cat. On a side note, the power of every public blockchain will be under threat from quantum computing power. It was no coincidence that the price of Bitcoin dropped sharply the day Google made its quantum supremacy announcement. Another area very relevant in these days is that it could speed up drug development greatly by reviewing multiple molecules, proteins, and chemicals simultaneously, quickly sequencing individual DNAs and providing super personalized drugs. Another area of application is weather forecasting, and even more importantly, climate change predictions. It will require the tremendous power of quantum computing to create the complex, ever changing weather models to properly predict and respond to the climate cataclysm that awaits us. Thus, it's a brave new world of quantum computing that we are entering into, and we will discover the possibilities as we go along. If you feel that you have understood what it is, yet continue to be confused at the same time, do not be disheartened. It is the nature of this beast. I encourage you to just step out of the box. Thanks for listening to me. As I said, every week or every alternate week, I take a technology and weave a story around it to try and demystify it. I hope that you understood a little bit of quantum computing today, a very arcane area. Do follow me on my channel, on my YouTube channel here, on Twitter, on LinkedIn, and you will have every update on my or every new video delivered to you. You could see that. Thank you very much, and thanks for your time.